Everyone, today we are going to learn about modeling inverse or inverse variation. This is an extension of what our last lesson was about, which is direct variation. So what I would like you to do in this lesson, before we get started, is this really quick warm-up, which is a really important skill that you're going to be using in this lesson, which is simply solving for y. So I would like you to please go ahead and pause the video and complete this warm-up before we get started for today. When you have an answer, please restart it and we will see how well you did. All right, so let's go ahead and talk about solving for y. We know that we're simply undoing the operation that's taking place. And to undo multiplication, we're going to divide both sides by x to end up with our equation of y is equal to 7 divided by x. Over here in number 2, we subtract x on both sides to undo the addition, and we end up with y is equal to negative x plus 3. Now, if you wrote your answer as 3 minus x, that's perfectly fine as well. And I'll write that down just so that you know that that's an okay answer. And number 3, I need to undo the division of 4 by multiplying both sides by 4. The multiplication of 4 eliminates the division of 4, and we are left with y is equal to 4 times x. And this skill of getting y alone is one of the skills that you will need for this lesson, because what we have here of looking at y equals equations, these different types of equations, will help us to decide whether or not we have an inverse, direct, or neither situation. And our learning targets for today are for you to be able to say, I can determine if an equation or table represents a direct variation or inverse variation. And I can write and graph an inverse variation given an ordered pair. And I can write and evaluate an inverse equation given a real-world context. So, in our last lesson, we learned all about direct variation, and that is where we had y is equal to a times x. Well, inverse, think of what's the inverse operation to multiplication. Well, that's division. And if you have two variables, x and y, that show an inverse variation, they are related as y is equal to a divided by x. So instead of times x, we're dividing by x. And that a value, once again, that constant value, is the constant of variation. And in story problems, we are going to be working with the language of y is said to vary inversely with x. And once again, this is what you're going to use in story problems. So this is story problem language. Let's go back to talking about a. In direct variation, what we know is that direct variation is related to, has an a value that is the slope, and the slope was y divided by x. So because this is inverse, the inverse operation of y divided by x is y times x, or simply x times y. So both of these equations represent direct variations. One is an equation that we will eventually graph in our upcoming units or lessons. And the other one is how you identify your your constant of variation from, let's say, a table of values. So in example number 1, what we want to do is show and state whether x and y show a direct variation, inverse variation, or neither. So essentially, just like our warm-up, we need to get y alone or solve for y. And by doing that, we will be able to see if our equation models direct, inverse, or neither. So let me show you what it's supposed to look like. Our warm-up. In our warm-up, do you see how number 1 is y equals a number divided by x, a over x, 7 over x? This is an example of an inverse variation equation. Number 2, do you see how we're adding or subtracting a number to x? Yeah, this is a linear function with you all the way, but is it inverse or direct? No. Instead, we call it neither. It's just a plain all linear. And number 3, this is a direct variation, just like the problems that we did in our last lesson. It is a number times x. So just like we did in our warm-up, we're going to do the exact same thing here in example number 1. So I am going to solve for x and see what ends up happening. So looking at letter A, I'm going to start by adding 3x to both sides. And when I do that, I end up with y is equal to 3x. That is a number times x. That's direct variation. Let's look at letter B. Letter B, I need to get y alone, so I'm going to start off by multiplying both sides by y. And then when I do that, I end up with xy is equal to 3. Now you can stop here and recognize that your a value in an inverse variation has to be x times y. And you can stop and say this is going to be inverse variation. Or you can keep going and divide both sides by x to end up with y is equal to 3 divided by x. And once again, that's still going to be an inverse variation. Anytime that you have a number divided by x in the denominator, you're going to end up with an inverse variation. Letter C, I'm going to subtract x on both sides, and when I do that, I end up with y is equal to negative x plus 5. And because I have that plus 5, that's going to be a neither. So now let's go ahead and look at letter D. Letter D is a little bit different. I have a table of values. So what I want to do is I need to check if this is direct variation. And as we learned in direct variation, we take all of our y values and we divide it by x. And we're going to see if this is a direct variation. So I'm going to write, is this direct? And I'm going to test and go 21 divided by 4. And I'm going to put that into my calculator. And all you need is just a scientific calculator. So I'm going to put this into my calculator. 21 divided by 4 is equal to 5.25. And then I'm going to test 14 divided by 6. And when I put 14 divided by 6 into my calculator, I end up with 2.3 repeating. Now, these two numbers are not equal. So therefore, what this tells me is that this is not direct variation. I don't even have to check anymore. It is not going to work. So now what I'm going to do is I am going to check inverse variation. I'm going to check, is our a value equal to x times y every time for it to be an inverse variation. So let's go ahead and check this out. I'm going to see if 4 times 21, that's equal to 84. 6 times 14, well, let's go ahead and put that into our calculator. 6 times 14, that is 84. And I have 8 times 10.5, I can see that that's going to be 84. And 8.4 times 10, I can see that that's going to be 84. And I know from my multiplication facts that 12 times 7 is equal to 84. 84, 84, 84, 84. So yes, this is indeed inverse variation. That's exactly what it is. And my a value is going to be 84 because all of my products ended up equaling that number. So if this problem had asked you to write the equation for inverse variation, we would write it as y equals 84 divided by x. And that would be our answer. And yes, this is going to be an inverse variation. Now, what I would like you to do is please go ahead and try the team and solo questions on your own and be ready to talk about those the next time I see you. Let's go ahead and move on to example number 2. In example number 2, it says that the variables x and y vary inversely. So therefore, I'm going to be working with the equation y is equal to a divided by x. In this problem, they tell me that y is equal to 15 and x is equal to 1/3. And I know to find my constant of variation, since we're dealing with inverse, that's going to be x times y. So I want to write an equation that relates x and y. And then after I have that equation, I want to find y when x is equal to -10. So the first thing I'm going to do is I'm going to identify my constant of variation. That's going to come from x, which is 1/3, times y, which is 15. This is going to be equal to 15 over 1, so that's going to be 15 over 3, which is 5. A is equal to 5, and my equation is going to be y equals 5 divided by x. So now that I know that my equation that I'm working with is y equals 5 divided by x, I am now going to let x equal -10, and I'm going to find y. So I'm going to write y is equal to 5 divided by -10, and that's going to equal -1/2, and that is my answer, -1/2 in terms of finding y. When you are ready, go ahead and move on to the next page. And next, what we're going to do is kind of bring it all back together. So the general equation is y is equal to a divided by x. The general equation is y equals a divided by x for inverse variation. And it can also be written as a is equal to x times y. That's just recapping what we already wrote on the previous page. What this tells you is that if we're looking at data pairs, and remember that data pairs are ordered pairs of x and y, they will show an inverse variation if the products of x times y are constant or approximately constant. So you might see in like some homework problems where you might have to round, and if that happens, then make sure that you round to the nearest tenth. Or hundredth. But what you're going to see is that when you work with those numbers, they will simplify it or round to the exact same number every single time. But it needs to be the exact same number every time. So looking at example number 3, it says moving curtains are manufactured in a variety of sizes and shapes to accommodate the variety of objects that need to be packed. The table compares the area of the bottom of a rectangular carton in square inches with the height of 4 available cartons that have the same volume. So what we want to do is we want to write an equation relating A and H. So just like we did before, we need to verify, is this direct variation or is this going to be inverse variation? So I'm going to check direct variation. If this is a direct variation, that means I need to verify that A is equal to y divided by x every single time. So let's go ahead and check. Is 24, so if you view this table as our A value is like our x's and our H value is like our y's because of the position that they're in, I'm going to go 24 divided by 50. And 24 divided by 50, according to my calculator, is equal to 0.48. And 12 divided by 100, I know is 0.12, and those two values are not equivalent to each other. So this tells me that I do not have a direct variation since these two numbers are not equivalent to each other. So now I'm going to check to see if this is an inverse variation, which means that I'm going to check every x times y. See, my A value is x times y. So I'm going to multiply 24 times 50, and 24 times 50 is 1200. 12 times 100, that's equal to 1200. 10 times 120, that is equal to 1200. And 8 times 150, if you put that into your calculator, that ends up equaling 1200 as well. So all of these values are the same, which means that yes, this is an inverse variation, and my A value is going to equal 1200. So now I want to write my equation. Since I know that this is inverse variation, that means that I'm going to be working with y is equal to A divided by x. But that's not my variables in context because I need to work with A and H. So since A corresponds with x and H corresponds with y, my equation is going to be H equals A divided by capital A. And since I know that my A value is 1200, I'm going to put that value right up top. So that's going to be h is equal to 1200 divided by capital A. And that is my equation relating H and A. So now what I want to do is I want to use this model to predict the height of the carton of the same volume as those in the table with the base area of 75 square inches. So what that means is I'm going to write H is equal to 1200 divided by A, but I'm going to let A equal 75. So I'm going to write H is equal to 1200 divided by 75. And I'm going to put that into my calculator. And what I get is I end up getting the number 16. So that means that H is equal to 16, but in units, height was in inches. So we're working with inches. So I'm going to write 16 inches. It will not be square inches because that represents area. So this is just going to be plain old inches. So let's go ahead and recap everything and bring it all back together. Direct versus inverse. A direct variation equation is a linear function. It is a linear function in which A is equal to the slope and 0 is going to be equal to your B value, or 0, 0 is your y-intercept. Our equation is y is equal to A times x. And our constant of variation is based on slope. It's going to be y divided by x if we're given in a table of values. And in words, you're going to see that y varies directly with x. For inverse variation is not linear. Instead, it's going to have two asymptotes with two branches, hyperbolas that are going to be on each side, and we're going to explore that in a future lesson. But our equation is going to be y is equal to A divided by x. And in ordered pairs, we're not dealing with slope. Instead, in a table of values, our A value is going to be x times y, not y divided by x related to slope. So it's completely different. And in words, we're going to write y varies inversely with x. So there's either directly or inversely. And that is the end of today's lesson. If you have any questions over anything I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.